Okay, so in this video I'm going to show you how to graph um, more complex trigonometric functions, and in this particular problem we will be graphing the sine function, so y equals negative 2 sine 2x minus 1 over 1 period. There are methods that are considered shortcut, but uh, I'll try to make the approach here something that is uh, something that you can um, understand deeply how the graph is created, because sometimes when you use too much shortcuts, you will miss the idea, and if you forgot how the shortcut is being done, then you won't be able to proceed. Okay, so in any trigonometric function, the first thing that you have to do is to identify the period, and this is true for the sine and cosine functions. The formula for the period for sine and cosine is p, the period, 360 degrees over the value b. So I'll be using degrees instead of radians. Okay, so where is this b? The b is coming from, so if y is a sine bx plus c, the b is the coefficient of x. So in the given, we have y equals negative 2 sine 2x minus 1. So the b here is 2. So if b is 2, so we have y equals, or rather, um, p is equal to 360 degrees divided by b equals 360 degrees divided by 2 equals 180 degrees. So the period, one period can have a length of 180 degrees from 0. Okay, and then once we have the period, we can already plot one period on the graph. So if we go back to the graphing area, we could have 180. So let's use every two grid lines as a as the main partition. So we have to create 4 partitions for one period. So we have 1, 2, 3, and 4. So this is your 180 degrees. Okay, so this is 180, and then for the other partition, it's in the middle is 90. This is 45 degrees, and this is between 90 and 180. That's 135 degrees. Okay, note this is the 0 degrees. Okay, so once you found the 4 angles and 5 including the 0 degrees, you should get the value of y, the function, for each identified angle, and that will give you the points that will lead you to the graph of the function. So let us list down all those angles. Okay, so we have 0 degrees, we have 45 degrees, we have 90, 135, and 180. So our goal is to get the y for each angle. So note the function is negative 2 sine 2x minus 1. Okay, so how do we do this? So for 0, the y is basically negative 2 sine 2x. 2 times 0 is 0, and then after that, that's minus 1. And you have to find the value of that. So you can use a calculator to find this. So just type in exactly what you have. So negative 2 sine 0. Make sure you use the corresponding parenthesis, and this should give you negative 1. Then you repeat the process for 45. So negative 2 sine of 2 times 45, and then minus 1 again. So compute. So just use 2 times 45 is 90. So that's 90. So it should give you negative 3. You can check by doing this also in your calculator. If the angle is 90, so you have negative 2 sine of 2 times 90 minus 1. So 2 times 90 is 180. So this will give us negative 1. And then if it's 135, so negative 2 sine of 2 times 135 minus 1. So you have, just use your calculator. So we have 1. And then when it's 180, so y equals negative 2 sine of 2 times 180. That's basically 360, and then minus 1. So we have, so you can compute that, equal to negative 1. So this is negative 1. So let us summarize the values. 0 degrees, it's negative 1. 45, it's negative 3. 90, it's negative 1. 135, it's 1. And 180, it is negative 1. So we will be placing these points on the given Cartesian plane. Okay, so let's start with 0. We said the 0 is at negative 1. Okay, so the first point, when the x is 0, the angle is 0, let's use a unit like negative 1, negative 2, negative 3, and 1 above. So the first point is at negative 1. Let's change it. Let's make the color red. So this is your first point. Okay, and then the next point is located at 45, negative 3. So when it's 45, it should be at negative 3. So this is your second point. When it is at 90, so the 90, see here, 90, negative 1. So 90, the point is at negative 1. When it is 135, it's 1. You see the list. So 135 is 1. Or 135. So 135 is 1. And when it is 180, finally 180, you have negative 1. So negative 1, 180 should be here. And then what you can do is you just connect the points, and this will give you an estimate for the graph of y equals negative 2 sine 2x minus 1. Okay, so see the graph. Okay, so wavy or wave type of graph. So this is negative 2 sine 2x minus 1. Now again, I use a method here in which we utilize the plotting of points. There is a method that you use like to translate, like move down by minus 1. You can also do that, but I avoided to do that because sometimes it becomes more confusing and students do not understand where the points are coming from. Okay, there are videos there are a lot of videos in YouTube that discuss how to do that, but I want you to appreciate how the points are identified. Okay, so the only thing that you have to remember here is the period. Okay, so once you have the period, all you have to do is to divide it into 4 areas, and then you can identify 4 angles, 5 including the 0 degrees, find the corresponding values of each, plot the points, and there you go. Okay, if they ask for the amplitude is basically the length from the middle, just in case you're curious on how to find the amplitude. Note this is acting like the center of the graph, this line. So the amplitude is basically from this line to the highest, so this is about 2, and then down to the lowest, that's about 2 as well. And this can also be obtained from the given function. So y equals negative 2 sine 2x minus 1. That measure is basically the absolute value of this. We call it the amplitude. Okay, amplitude A. So I hope you understand how to graph the function. So that's it.